So we've structured this session around three global grand challenges in public health. And that's firstly, prevention of zoonotic pathogen emergence, both thinking in terms of upstream prevention, so the upstream precursors to pathogens spilling over from animals into people, and then the interfaces at which this pathogen transfer and spillover occurs. Secondly, the control of transmission once pathogens have emerged into human populations or for pathogens that are already endemic and circulating within peoples. And then finally, equitable access to healthcare. And I think what's really worth pointing out here is the word global. So these three challenges apply to the global north and to the global south. And as a result, they're a really fertile area for knowledge exchange and for collaboration. So in reality, these challenges exist within really complex social and environmental systems. And I don't think you can really make it out terribly well, but this rather daunting looking systems model is from a systematic review that Dishon, who will be speaking as part of this session, and I have been working on to try and look at evidence linking public health to social systems and the environment on the African continent. And so the nodes within this network that you can see, the colored circles, they represent components that are present in the literature. And where there is sufficient evidence to suggest a connection between these components, whether it's through upregulation or downregulation, they're connected by either solid or dotted lines. So the different components you can see here, it just shows how tightly linked infectious diseases in public health are to climate change, agriculture, changes in land use, and then ecosystem integrity. And infectious disease sits really right at the center of this system. It's connected to all these different components. Now, in this projection, the size of the nodes within that network are weighted upon out degrees. That's a measure of the different outward connections that each component has with the rest of the system. So it really highlights those components that have a considerable impact system within which infectious diseases and public health are nested, such as climate change, agriculture, pollution, ecosystem health. But we can also change that projection so it looks at incoming connections. So these are the components that are really heavily impacted by changes that occur within this system. As you can see, infectious diseases is right at the center there. There's also human health, pollution, biodiversity, and food systems and poverty. So I'm going to now hand over to Mercy to contextualize this a little bit within landscapes that you'll be more familiar with.
And talking about conceptualizing infectious disease systems across scales. And I think of importance are the drivers of infectious disease in these changing landscapes. So to my far right and your far left, we see a driver that is known as deforestation. And the beauty about the infectious disease session is yesterday you heard about climate change and you heard about biodiversity. And so they gave a good background from which we can pick up from. And so with deforestation and other anthropogenic activities such as pastoralism, you find that the degradation of land, encroachment into habitats, amongst many other things, lead to emergence of disease because of changes in behavior, both for humans, interaction between animals and wildlife, and even changes in vector biology for those who work with in the vector arena. And so with this particular changes, it's likely that there will be emergence of diseases. And then if you move to the smallholder agriculture, and here we see issues like husbandry practices, for example, antibiotic use to treat livestock that are there, as well as issues like use of fertilizer, talking about waste management, water pollution, sharing of available resources such as water amongst different groups of people. All of this impact on the emergence and possible spread of disease. And then we go to the very far, my extreme left, which is your extreme right, and we have urbanization. And we all know with urbanization, there's many things. I mean, one good thing is with urbanization, there's probably improved road networks. And what that means, it's better access to healthcare. And that then leads to more population growth. But the downside of this is then when there's a disease, transmission becomes a big issue, and control, and also the fact that there's increased mobility as well. So you can see that many different landscapes. And so with these different landscapes, then we expect different drivers of disease. So as I had mentioned, right at the my far right, is with deforestation and other systems, we expect the emergence of disease, but also the practices of smallholder agriculture also leads to emergence of some diseases as well. And then we move to spread of disease or more of transmission. But then at the very end, we have aspects of control and prevention in terms of predicting, to help us predict future threats and how to possibly mitigate them. So to start us off today will be Barbara Han, who will be talking about how she uses ecology and AI to predict future of emerging diseases, followed by Dishon, whose work actually cuts across a bit of emergence and spread as well. And he will be talking about antimicrobial resistance interfaces, as well as genomic surveillance. And then we'll move to Amy Wesolowski, who will talk about the utility of using mobility data to understand disease transmission dynamics. And finally, where control is concerned, we will, Esther Buregea will talk about mobile technology to support prevention and treatment of endemic pathogens. So I do think you're all in for a good treat.